Hey Dr. Salim, it's me, coming to you with part 2 of my project. Originally I was just kind of going to sit down and scroll through my code and explain what I was doing, but as you can see, the camera on my phone doesn't actually focus, so you wouldn't be able to read anything, so it'd be kind of pointless. So what I'll do is just attach the code to an email, and then I'll explain anything I don't cover in this video in there. This video is pretty much just going to be basically like the hardware connections and stuff that I had to make, and then I'll demonstrate how it all works. How it takes all the information, sends it, and displays it on the laptop. So here we go. Okay. First, here are my new components. I've got the PIC processor on the right that I'm using, and along with this breadboard that just helps with the circuit connections. The PIC is responsible for collecting all the data. In this case, I've got 3 inputs, and then displaying them via the serial port on the laptop. My first input is just the frequency, and that is used to calculate RPM and speed, as you'll see in the code. All I had to do for that was the variable frequency drive has this. I know you can't read it because of the focus, but it says FQ, and that's the frequency output. Whatever frequency is being output on the VFD can run into another device, a frequency meter. In this case, the microprocessor is acting as my frequency meter. And then CM is just the common ground, so that's just where you ground it, obviously. And that, if you follow the thin red and black wires, run down into my breadboard, and then into the ground of the microprocessor. It's the black wire. Okay, and that's my first input. Simple. Second input is how much charge is left on the battery, and the important thing to understand here is that the microprocessor can only handle up to 5 volts, a 5 volt input, and this is a 12 volt battery, which is actually 12.23 volts when fully charged. So obviously I had to scale that down, and the way I did that, also with the help of the breadboard, is a voltage divider. The resistor on the right is a 15K, and the resistor on the left is a 10K, and that's actually designed to scale down a 12.5 voltage down to 4.9, which is acceptable for the microprocessor. That little red wire in between them is actually where I'm taking my reading from, so that's 4.9 volts when this is fully charged. And anyway, if you follow that red wire from in between the resistors, that just runs into my second input of the microprocessor. So, done and done. And then, let's see, the third and final input I have is used to sense when these batteries, my storage pack, if you will, I'm making little quotation marks, but when that's actually charging. So this will tell you when your car is charging or not. And as you can see, the red and black wires are just attached to either end of the poles of the batteries, and that's run into the breadboard and then into the third input of the microprocessor. So let me go ahead and display how this works. I'm not gonna display the charging right now because I'm in the manual setting and my pedal is made of metal. So if I'm pushing that down and I attempt to engage the dynamo, also made of metal, I will actually short the circuit and receive a shock. Trust me on that. It happened. So I'll go ahead and display my first 2 inputs, which are battery charge and RPM and speed. And basically, let me go ahead and turn on the serial port monitor. Hopefully you'll be able to see, I don't know, at least some values, but I don't know. Norton's performing a full background scan, so awesome. This is going to run way slower than I want. Alright, here's my serial port monitor. The values, once I hook up my microprocessor, are going to appear just right up there. So, let me go ahead and take power and put it into the microprocessor. Hold on, things are going to get crazy for a second. Okay, I've plugged in the microprocessor, and as you can see, my values came up, and again, it's not focusing, so it's a little hard to read, but that says RPM. It's at 0 RPM right now. That one's speed, 0 miles per hour. That's my battery charge, which is at 56, about 56% right now. And that fluctuates a little bit, which I'll get to later. And then am I charging right now? Obviously not. My wheel's not even moving, so it says no. And then the brake type, I'll explain that later as well. So, let's press the pedal, and you'll be able to see the RPM and speed values change. Well, let me actually run the motor first. Okay, here we go. Now as I press down, you can see the RPMs and the associated speed. And I'll explain how I calculated those in the email. Push down, go faster, faster. And my top speed, this motor's synchronous RPMs is 1800, so when I push it all the way down, that's 1800 RPM, and so my associated top speed is 21 miles per hour. Then as I let up, those values will drop back down until I reach 0. Hooray. Okay, and then the battery, here's the current charge on it right now. Again, it's about 56, 55. But as I press down, it uses more of the battery power, so you can see that start to drop. It drops by about 10% if I go to full speed. Oh, it's more like, yeah, about 10%. And so that's how those two work. Alright, let me go ahead and do charging. In order to not shock myself, I have to set this to automatic mode. So let me go ahead and do that. Okay, so I'll just run it at 30 Hertz for the purposes of this demonstration. So here we go, I'm running, and then I actually have this hooked up to the battery so we can kind of see at the same time how it charges. So they're at 1.24 volts right now. Now I'm going to flip this on, and when I do, you'll hear it. You'll see the charging change from a no to a yes. And as you can see, charge is increasing. And then as they get close to full, the charging slows down. And once it slows down enough, it'll go back to a full no. And I'll explain why that happens. I don't know if you could hear any of that, but once it charges to a certain point, it starts to fluctuate between no and yes until it gets to a full no, and I'll explain why that happens in the email. So, there you go. My batteries have charged up, and that's that. Okay, just some other hardware notes. I've got 3 capacitors in here, 0.5 microfarad for each of my inputs. One there, and then one up there. And those are decoupling capacitors. They're just to help with the fluctuations. When the microprocessor's analog to digital conversion unit makes a reading, it actually sinks the current a little bit, so your readings fluctuate. Well, the capacitor holds on to the correct current, so it can make a proper reading without fluctuating. That's pretty much the essentials of why those are in there. Anyway, I'll explain everything else in the email, as I said. I'm trying to think if there's anything else I need to show you here. I don't think so. So, okay. Have a good one. Let me know what you think. Later.